Hello, I am back at it again with another Sudoku today, and I haven't yet read through any of the rules or anything, so I guess let's start off by doing that. This one, once again, was one that was featured on Cracking the Cryptic a few days ago as of me recording this video, and it's another Fog of War puzzle, which are my favorites. Has standard crop key rules in it, where black dot ratios are 1 to 2 and white dots have to be consecutive. It's got quads, odd, and we have spiral galaxy. All cells must be part of a galaxy, and each galaxy has no repeats and adds up to 27, and all circles are the centers of galaxies, and every center of a galaxy is a circle. Okay, so first of all, I'm just going to mark that as the center of a galaxy. This white dot here is the center of a galaxy. This one here is. This is a quad right here that's getting made, and here is another quad that's getting made. Okay, so these are our starting galaxies. And I might as well pencil mark in this. This has to be a 5 or a 7 since it needs to be, well, it just needs to be one more, or one less than 6, and I can mark that there is a 4 in here. Now, I'm going to use the color. I'm trying to think there's a good way for me to mark, per se, like that this 6 cannot include this, because 180 degrees opposite is that. I can't think of a great way to do it. I'm just going to use black to represent areas that I have determined as not being things the one adjacent to it can go to, for now, out of lack of a better color, really. But this is what we're starting with. So if we look at this, and this sums up to 14, and all galaxies need to sum up to 27, which actually means I can get rid of that. For this one, at least, I can deduce that it needs to be at least 2 more cells, because it doesn't add up to enough yet. Same logic can be applied to this one, which means I actually know that this box here is done because it can't go anywhere anymore. So, yeah. I'm just going to forget about that for now because this seems a lot easier. So, we already have a 4 here, which means the remaining 3 need to add up to 23, and there is only one way to do that. So now we have this is 4, 6, 8, 9, quadruple. And here we're either adding up to 11 or 13. Here, no great indication. This one has at least a 1 in it, which means it definitely is not just 4 cells, because the largest the other 3 can add up to is 24. Anyways, if we go back up here, we're at 14. This guy needs to get up to 27, that is 13 more. And the smallest sum of 2 digits is 7. The smallest, because it would be 2 plus 5, the smallest sum of 4 digits is 2 plus 5 plus 7 plus 8, because of uniqueness for this galaxy here, and that is clearly going to be way more than 27, so we need a group of 2 cells coming off of this that add up to 13. Now 13 can be 9, 4, which doesn't work because there's already 4 in here, 8, 5, which would work, and 6, 7, which also doesn't work, so we know this is an 8, 5, which I'm just going to pencil mark in here. I need to have a 5 and an 8 in this galaxy. Now then, this cell here has to be part of a new galaxy, and it must extend at least 1 upwards, because you can't have a 1-cell galaxy that is going to work for making sum of 27. We also can't have a 2-cell galaxy, but I don't have an indication as to whether it's going to be something like this, or, for instance, something like that, or that, although I don't feel like this one numerically might. Actually, I think it might actually be possible. No, it is not possible, because 9 plus 8 is 17, which puts us up to 44. And 20, we cannot, yeah, the maximum number that could not be included in this would be 17 of the 45, so it's either this or that, realistically. Which means I know this cell's part of it. And if it's this that's not going to work either because then these two cells are here. So actually, I think that's the only possibility. Which, yeah, because it needs to be rotationally symmetric, which means that there's a crop key of some sort in between these two cells. I think that is all the information I can get out of that for now, but that also tells us we have another one here, which has to be rotationally symmetric. So, no, my conclusion is not guaranteed. Because it could be something like that as the add-on, for instance. So, there's definitely more possibilities than I'd let on, so I'm just not gonna try solving that yet. Either way, those two cells need to be like this, because I can't get purple or pink into that square. For here, this guy is already solved in terms of numbers. That one is almost certainly not. But I have realized that 8 cells cannot ever add up to 27, because there's simply just too many numbers in there. The smallest you can get will be the sum of just the 8 small ones, which is 36. So, yeah, either way, this one can only extend out one on each side, just like this one. So, yeah. If this one extends here, let's think about what happens. Then we're going to get some shape like this, which doesn't work out. There's just really no way to make this rotationally symmetric, so I think we can safely conclude that is like that for the galaxies, so I'll just mark those two in. And okay. Because every cell needs to be a galaxy. Why are they going to galaxies? All cells must be part of a galaxy, so I'm going to get rid of these because those are messing me up with this. That's definitely where the error was showing up for my previous logic. Because, for instance, I could have something like that. I don't have any great ways to determine yet what the shape of this is, because, like, there's a lot of options out there. But we'll see in due time where this ends up being. These two cells are part of a galaxy as well, like that. For this group of 4, theoretically it is possible for this to add to a group of 27, so no great way to determine if this extends one more like that or not. Okay, so one of these has to be a 6, or accurately one of those for that box, because it can't be in this column, and it can't be in this square because then it would, actually it could be in this square, so one of those is a 6. Okay. I have not found any gray circles yet. And are there any other specific rules about quads? There's just the big white circles must appear. They don't necessarily need to be in order, I assume, because otherwise that would be impossible. All the circular clues are centers of galaxies, yada yada. If we have this one extending over here, then we get this pattern for the initial group, which the only way it can be rotationally symmetric is like that. Now that's not possible, so I can use the exact same logic I used on the other one up there to determine that is the shape of this galaxy. And then I can make this group of cells some color, and that group of cells some color. And this one cannot go up, because if it goes up, it can't possibly come back down, so this one has to be at least 2 cells longer, and that tells me that this cell must be a red and this cell must be a red. I'll get rid of these. Now the red galaxy is also finished. And this guy cannot ever move up, so this and this must be the same color. And that's going to cause me to have... Oh, okay. So the only possible way now for this one to work out is that if it is also a straight line, so it's going to go up there. And then this galaxy here, just make yellow, it's at least like that. And this green one needs to extend one further, so we have some galaxies in here. This cell has to be the center of the galaxy. which means there's only one type of clue that is in a single square, and that's going to be a gray circle clue, which tells me that this cell and also this cell, for the same reasoning, are both odd numbers. For this one, I do not know if it's shaped like that or this, so I cannot deduce what its shape is like yet. This guy is obviously like that. Okay, so how many ways, if we have 6 cells inside the galaxy like we do for this one, that means 3 of the 9 cells are outside of it, and those 3 cells need to add up to 18. Can we, what is the largest number we cannot have? So we can make 18 without a 9 pretty easily. Can we? Can we make 18 without a 9? Oh, yeah, of course. If you do, for 18, for instance, if you do 7, 8, and 3, that makes up 18 without 9 and works. So, we do not have a great way to determine if 9 is included or not in this group of cells. We need to make 21 out of those, which I can't figure out yet. Okay, so there's a group of 5 here and a group of 5 here that add up to 27, which means 18 needs to now be made out of a group of 4, which there isn't really any restrictions on that either. Okay. So, this guy is either like this or like that. And those are the really only 2 possibilities for shape, because it has to be a maximum of 6 cells. And it needs to follow a rotationally symmetric pattern. So, no matter which way it is like, this cell is going to be part of some new mystery region, which I will color that color. And no matter which way it goes, that region has to extend at least here. Yeah. Not much is guaranteed. Maybe the way to go about this, I don't think parity is the answer, but maybe it is. So, these cells are going to be odd total, which means that these 4 cells must be even for total parity. This one is already even, so these 3 cells must be even completely. Also, this one can't be a 9 because of that square. I missed that one as initially marking it. These 3 need to have a total parity of being even. This group of cells already has a total parity of being odd. This cell is guaranteed to be odd, so these 2 are odd. This is even, which means the sum of these cells is all odd, which means this cell must be an even cell in order to keep this square complete. So apparently I was wrong. Where did I go wrong in that? Because it would have unfogged if I had been correct. And this group of cells here adds up to 27. Plus this cell is going to be 33, which means these cells add up to 12. Oh, this is odd and this is odd, so that makes a total of even, so this is actually odd. That was my error. Now we know this cell is also odd. There's a 2 in that clump. Can we do the same trick over here? I do not think so. Yeah, I don't think so. Well, anyways, we know this group of cells is odd. These 2 cells add up to an even number. And this group of 3 cells is even. It is 1 even and 2 odd numbers. Okay. The other way I can think about this is trying to find out how many groups of 27 can fit in 3 columns, for instance. 3 columns of cells adds up to 135, and if we take that and divide it by 7, I think we can have at most 5 total in 3 columns, because 27 times 6 gets us over 160, but 27 times 5 puts us at 135, which is exactly the same. Okay, so yeah, for every 3 columns we have exactly at most 5 galaxies per. as in we need to have 5 galaxies per every 3 columns, so there are 15 galaxies total, of which 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 have been started. Which means that there are 4 more in there somewhere. Additionally, in this column we already have, or in these 2 groups of columns, there should be 10 total. Complete ones within them. We have 1, 2, 3, 4, 5, 6, 7 guaranteed to be completely within them. So that's not super useful, but now I know that, I guess. Let's see. This one. This one is 2, 1, 3, 5, 7. This 5, 7 here cannot be in any of these cells or this cell, so one of these 2 is the 5, 7 from over here. And that's just guaranteed to be the case. Additionally, these 3 cells cannot appear in any of this area, so they must be in this group of cells. Okay, that's not super helpful either. We're trying to... I think the next step might be I have to determine how many ways there are to make 18 out of 3 cells. Because if we have no 9 in here, then we need to get 2 numbers that add up to 9 that do not conflict with anything out here, which could be 1, 8, or it could be 2, 7, or it could be 4, 5. So, if we don't have 9 in here, that's going to be a problem. Or, yeah, if 9's outside of here, we can't deduce anything else. If we have 9 inside here, then we can try doing it without 8, in which case we need 2 cells adding up to 10, and the only case is 3, 7, so 8, 3, 7 is a possibility. If both 9 and 8 are in here, then this first smallest is 7, so 11 can't be 2, 9, 3, 8, 4, 7, or 5, 6, so we would also need to have 7 here, and then the smallest we cannot have in here is 5, and that breaks, so at least one of 8 and 9 are not in here. And that is good to know. That doesn't restrict any numbers from being outside of here at all, because the only one that couldn't be, that had to be in here with 9 was 3, and that number can be excluded if 9 is included in here. Because yeah, 6 is already in here. This group doesn't have a 6 in it. That's 27, this is a 6. These 3 add up to 12. Minus 2 means the remaining 2 add up to 10. And the only way we can make 10, because we can't do 1, 9, 2, 8, or 6, 4, is 3, 7. So this is actually a 2, 3, 7 group, which means that these 2 are 1, 5s. Now that's actually something. That's no longer a 3 or 7. This is a 1, 5 pair here. There's no 1s there. One of these 2 is a 1. Now then this group adds up to 6 as well, which means we get 21 out of these 3. Which means this can't be a 2, because then we would need 19 in these 2 cells, and the largest we need in 2 cells is 17. So this guy also is in a 3 then, because that would mean 18. So this is a 7. It actually lit up that time, which means I didn't make a mistake. And I'm guessing this one might just not include any other numbers in it because it's forced. So that's probably why that's not showing up. Means here we have 2, 3, and a 6 now. So now we know this group adds up to 11. This group here needs to add up to 16. So there's 2 cases. If this is a 5, these 2 need to add up to 11, which can be done with 4 and 7. And if this is a 7, these 2 need to add up to 9. And the only way we can get that is with 1, 8, or 4, 5. Yeah, well, 1, 8 doesn't work because then these 2 have to be 5, so it's 4, 5, or 4, 7. So we have a 4, 5, 7 triple here. Makes you a 1 and you a 5, and makes you an 8 and you a 5. And now we know this is the center of one, so in order for it to be the center of a galaxy, it has to be like that, and that gets us this. These 2 are part of a galaxy, and they can't connect up to this one. because it is simply too far away, so I'm going to make this one be, I'll do orange. These two can't be 8, one of these two is an 8, these also can't be a 6, so I'm just going to get rid of that and mark it as a 4-8 pair. There can't be a 4 here, there's a 4 over here. That's a 6-9 pair. Here we have a 2-3 pair, no 3 here. I'll get rid of all this again, and I'll go with 3-4. And okay, there is that done. These 4 cells over here need to be 2, 3, 7, and 9. This one cannot be 2 or 3, so it must be 7 or 9, which makes this a 6 or an 8. And here we have 2, 3, or 9 because we can't have a 7 in here, so this is a 7. If we have 2, 3, 9 here, and this guy could be an 8 if that's a 9, or it could be a 1, 2, 3, or 4. It can't be a 3, 4 because of these, so it's a 1 or a 2. Can't be a 2 because of this, so it's 1 or 8, and that can't be 3 because 2 and 4 both can't be there. This is 2, 3, 9, which adds up to 14, and 27 minus 14 is 13, so if this is a 1, these need to add up to 12, which, well, I'll actually do the 8 case first because I've seen it broke. So, this is 8, these need to add up to 4, which means we get 1, 4, or 2, 3. 2, 3 isn't possible, 1, 4 isn't possible because of this, so this can't be an 8. So we get it's a 1, which makes that a 2, so I can mark those in. Then I also know that here I have 1 and 8 pair, which I could have marked earlier. That's now just a 5 or a 9. This is a 4, 5, 9 triple. That can't be a 5. Okay, so now we have 3 plus another 3 plus another 9. So, oh, whatever, these still need to be 12. Okay, so we can't do 3, 9. We can't do 4, 8 because of this group up here, so these must be 5 and 7. Now, let's look at this group down here, because I can probably determine the numbers as well. These add up to 13, which means these add up to 14, which is 5, 6, 8, 9. Can't be, well, it's 5, 9 or 6, 8. Can't be 5, 9, so it's 6, 8. Well, that makes this a 6, 8 pair, which means these remaining 2 cells now must be 2 and 9. And this is an odd, and also the center rotationally, which means that this one's shaped like this. I'm going to get that these cells are blue now, because that's the color I've determined for them. This is a 3 or a 7 because it must be odd. We have 9s in those, so we can have a 9 down here. Okay. This is the center of that galaxy. Okay. Well, down here we have a 2, 3, 4, 9 quadruple, which I don't think will particularly help right now, but here's a 5. These 2 cells add up to 11, so the remaining ones must add up to 16. If we have a 3 here, we're going to need 13 for the remaining ones, which can't be 4, 9, could be 5, 8, and could be 6, 7. So 5, 8, 6, 7. If this is a 7, then we need these 2 to add up to 9, which can't be 1, 8, can't be 2, 7. It's either 3, 6, or 4, 5. So that's not really distinctive enough. I can just determine there isn't an 8 here, because there's no way to add up to, if there was an 8 here, there's no way to make these 2 add up to 6. So no 8 in this group. So 8 is in one of these 3 cells. Thinking about it, this galaxy has to be like this in order to fit, which means that this red one goes at least 2 cells up, which means it just goes like that, and this one must be odd for the center. Okay. Now then, how many galaxies are we at? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I believe, unless I've miscounted. 6, 7, 8, 9, 10, 11, 12. Okay, 13 actually, which makes more sense. I'm looking at the numbers. Actually, I don't know why I marked that, because this could be a 6 long. So, there's no way to know, actually, for that part. I think I was just getting a little ahead of myself, I guess. Okay, let's see. Here we have a 12, which means the remaining ones add up to 15. So if this is a 6, then the remaining ones add up to 9, which is going to have to be 1, 8, or, yeah, just 1, 8. And if this is an 8, then the remaining ones add up to 7, which has to be 1, 6. So this is going to be 1, 6, 8. There's no 1 here, so I get a 1 there. And that's not going to clarify anything for me, that being revealed. I just know there's a 1 in one of these two as well now. Additionally, that could just be a straight line, or it could be something like, well, it can't be something like that shape, but it could be something like that, for instance. Well, I don't think it could be something like that, but I'm not going to go guessing on the galaxy shape yet. I do know that's one of the two forms of crop key, not sure which. For this group of cells, I still don't think I have enough information to identify yet what's going on. Here we go. I have a 4 in one of these two, and I have a 4 in one of these two, and for some reason I can't have a 4 here. I don't think that is ever actually the case, so I don't know why. Oh, because it has to be odd, yes. So 4 in those two. There's a 4 in that row. One of these 3 cells is an 8. Oh, that's another 6-8 pair. I can't have 7 in either of those. What all do I have left for this column? 2, 3, 4, 7, and 9, right? 2, 3, 4, 7, 9. Yeah, the numbers add up. This can't be a 3 or 4, so this one up here is 2, 7, or 9. Down here, I can't have 7, so it's 2, 3, 4, 9. And that means I have a 2, 3, 4, 9 quadruple up there. Well, first of all, this one is 3, 4, 7 because it can't be 2 or 9. Okay. So here I have a 2, 3, 4, 9 quadruple plus a 1. So 1 plus 9 is 10 plus 4 plus 3 plus 3 makes 19, which means I need the remaining one to be an 8, I believe. 1 plus, so yeah, the remaining one has to be an 8, so I have 1 8 pair there, which is going to solve these two, which is going to give me there's no 4 there, so there's no 4 there. 1 8 here isn't going to really deduce anything else. I will mark that there's an 8 in one of those two squares. Oh, actually this one just has to be a 1, 7, 8. There's the center of that one, which is okay. So this is either a 1 2, a 2 4, or a 3 6 pair because it can't be 4 8. 1 2, 2 4, 3 6. I do not think that is helpful, so I'm going to not have it. Actually, this one's either 2, 3, or 4, because it can't be a 6, 8, or a 9. This one's 2, 3, or 4, which makes this one 1, 2, 4, or 6. Okay. I will go back to maybe looking at... No, I don't think there's anything new to be gleaned there right now. Yeah, that's not going to give me any new information, I don't think. Unless it might, actually. So, here's 11. These 3 need to add up to 16. This is 3. These 2 need to add up to 13. And 13 can't be 4, 9. It had to be 5, 8, or 6, 7, which are both still possible. This is a 7, then this has to be either 5, 6, or 8, 3, I believe. No. This is a 7, and the remaining ones have to add up to 9, which can't be... So it has to be 3, 6, or 4, 5, which doesn't deduce anything yet. Either, okay. Can this guy go down, actually? If it goes down here at all, then this would have to be the pattern, or this would have to be the pattern. The second one obviously can't happen, because then that's going to make that shape, which doesn't work. And this pattern wouldn't happen, because we would need to have something here. So this one cannot go down here, must go over at least one more. Can't go down here because it breaks, so it must go over another 2 then, and this is just a 5 long. 1, 3, 5, 7, 9, which means that these ones have an even total sum. That's even as well, so these 3 need to add up to an even number, and there's no way to force that. Or deduce anything about that, because any of these could be even or odd. Well, at least there's that one done. So, I can't have a new one starting here. Because if I do, once it goes out 3 cells, it can't do anything else except for go out a 4th cell. But 4 cells could make a sum. So actually I'm gonna... Well, for this one I can determine it's not 4 long because there would be a symbol there. This one could be 4 cells long. And if I count the number I totally have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, still missing 2 in this area. So if one of them was, well, yeah, if one of them was horizontal, then that would suggest this one. Also, oh no, this one can't be a horizontal, it can't go any further that direction, it has to go up or down. And it can only go up or down 1 here or 1 here, so it must at least do this one. And then it has to do this one because it can't go anywhere. So the center of the galaxy is, yeah, that group of 2, which means the shape is valid. And now, I'm guessing this might be a block of 4. Can it? Can it be a block of 4, actually? Well, I'm going to remove this though, because there's no guarantees that this isn't a line of 4. Thinking about it. How many cells do we have left in this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there needs to be one odd clump. The odd clump has to hold on to, well, okay. So I think there might only be one possible way left to make these shapes. I'm just gonna mark this one as this because these 4 cells need to be connected, and I can't make a 7-cell long one. And then the only other symmetric shape I see is this, which means that this one does have to be a 5 long. Yeah, that's the only possible way left. So this is another box of things, which reduces its possibilities some, but not enough. Also, I don't know why I made this one blue, and that's one of the colors of things next to it, so I'll switch it to green and get rid of the blue coloring. And there we go, I've got all the boxes done now. So I just need to figure out the numbers that go in all of them. So can I do this without 9? 8 plus 7 is 13. Plus, well, 13 is already less than half, so no, I need a 9 in there. So one of these 2 is a 9, and that means the remaining ones have to add up to 18. Can I do that with just... Well, yeah, I can do that without 8, because 7 plus 6 plus 5 is 18. So I need to have 8 or 7 in here. That's a guarantee. And because of that, any other number could be a possibility. So I'm not going to get anywhere by pursuing this box right now. This box here, or, well, this galaxy here, I don't think I can get anything else out of right now. This one up here, I think I've got all the information I can get out of it. Fortunately, same for that one. I'm trying to think about what the next step for me is going to be. Okay. I know that this one is a crop key of some sort. This one also has to be a crop key of some sort. That one doesn't tell me anything because it's just a quad, so no information can be gained from there. This one is a crop key of some kind. Can this one be a black dot? It would be 2, 4, 4, 8, or 3, 6. I don't see any reason it couldn't be one of those. Because this could be 8, 9, this could be like 6, 5. There's no real restrictions on where this one goes. This one could include the 4, and it could not. There's not a great way to deduce whether it does or not. Well, at least has an interesting pattern going around. There's these shapes everywhere, which I had hoped I could use more deduction similar to the these 2 on the other ones, but I don't think I can. It's the issue, because I don't have enough information around there yet.
So one of these is a 4, one of the... Yeah, I already noticed that. The 9s I've handled. Down here, I just need to have an 8 in this or one of these two. And there is 168 here and 168 there. Does this one need to have a 6 or an 8 in it for here? This 3, 7. That was 2 plus 9, 11 means 16 for the remaining ones. If it's 15, it's 8, 5, or 6, 7. And if this is a 7, or no, this is a 3, this is 13, which is 8, 5, or 6, 7. And this is a 7, and the remaining ones here are 9, which is 4, 5, or 3, 6. So, no, this one could be 6 or 8. This one could be another 6 or 8. So that's not going to clarify anything yet. That box just needs to have a 9 in it. This line can do without a 9 in it, so there's no restrictions there. In fact, that one doesn't have a 9 in it. Okay, let's think about this. These 4 cells need to add up to, whatever it is, 18. Which means, oh yeah, here we go. These 3 cells need to add up to 10, so this one can't be 6, because then that would have to be 3, 4 minimum, which is greater than 10. So I can determine those. These 2 have to then add up to 9, which means this one can't be that. And that makes it clear which one that is. And since some of the areas with fog on them are lighting up, that means I'm on the right track. Or at least I didn't get those ones wrong, necessarily. I don't think I can do the same thing there because I don't have information right now about that. But now I know that these are 2, 3, 6, 7, 9. I'm not going to fill that out for all of them because that's too much information to fill out. I think I will fill out this one though. 1789. Maybe this is going to not help me at all. It looks like it's not going to help me at all actually, so I'm just going to get rid of it. Okay, I've at least gotten these ones sorted. I now know there must also be a 5 down here, so this is 4 and 5 already in here, which means this might be another adjacent one. I now know I can't have an 8 in this or a 2, so this is down to being... Okay, this one needs to be 4 or 5 or 5, 6. So there must be a 5 in this group of 2 now, because it needs to be greater than 3 but less than 7 for the bounds here. So 4, 5, or 5, 6, which means this one must be a 5, and that makes this a 6, which makes this a 2, 4, and that an 8, and that a 6 and an 8 and a 6. And that's going to give me some information about what's going on here. So this is 7, then these 2 need to add up to 9, which makes this a 4, 5, and if this is 3, then these need to add up to 13, which has to be 8, 5. Right, yeah, because it can't be 6, 7, since 6 is here. So this is now 4, 5, 8, with 5 already forced. So, I could have also found out from the fact that it's probably 5 here. So, here we go. That's a... and then in that case, I have... still no new information, or minimal information, I guess. I'm gonna re-put in the 1789 just so I can get my bearings straight about what numbers can be in these cells up here compared to these boxes. So this is already 11. I need 16. What sums of numbers can I get up here? I can get 1 plus 7, which would be 8, which would make the bottom 2 need to be 8. That breaks, so I'm not going to have that. I could have 1 plus 9, which is 10, and makes the remaining ones down here need to add up to 6, which can only be 2, 4, so that is the first case. This is 2, 4, which would be... I get that. If I don't have a 1 here, then these add up to 16, which is already the max, right? Yeah, so I need to have 1 and 9 here, and 4 and 2, and then I don't have a 4 here, so that's a 5, 8, which means that this one needs to be 3. That's a 7 now. No 4 here, no 1, 2 there. That still could be either of the two. That's a 2, 3 pair, so this is a 9, and this is a 4, and that's a 6, and a 2, and 3, and then there's no 2 here. There's also no 9 because of that. So I'm going to get this, and then I'm going to get that, and now I'll have a 5 here. This has to be a 7. That has to be a 4. Here's an 8. Here's a 5. Here's a 9. Here's a 3. This one here is 3 or 9, or not 3 or 9. That's a 1, 9. That's a 1, 9. Here's 7 and 2, and no 7 up there. And this is now a 3, 6, 9 triple, which 3 plus 6 plus 9 is going to be 18, 20, 27. That works. Here I have, well, this has to be a 9 now, which makes that not a 9. But obviously that circle has no information in it because at this point that information will not be helpful. There's already an 8 and 1 in these two, so there's no 8 here, which makes this an 8 and that a 1, which makes these two a 1 and a 5, which, just doing a quick sanity check, that's 6, this is 6, so that's 12, plus 15 makes 27, that works. So we're still good. In this row I need to have 6, 7, and 8. This one has to be a 7 because of the 6 and 8 down there. So there's that. And here I have 3, 4, 9, no 9 there obviously. 7 plus 9 is 16, means the other ones add up to 11, which can only be 3, 8, because 6 will need a 5. Okay, and then I can solve, looks like all of the top box, and a solid portion of the middle box, and there's that. Here's a 1, 5, 7, has to just be a 1 or a 5, which makes this a 2, and that's also a 1, 5, 7, but can't be a 1, so it's a 5 or a 7. Now here I have 9 plus 10, 19. I need to have 8, which can be 1 and 7 only. So that's going to get me done with the puzzle. And this one's probably one of the trickier ones I've done on the channel, at least so far, but I quite liked it. I guess I'll see you next time I see you. Bye.